Alright, gonna get this point slope form, which is a form I would imagine none of you have seen yet, but it is very efficient in that it combines kind of it changes slope intercept into an easy way to use when you have a point and a slope, thus giving it its name. It's easy to use when you have the point and the slope. Suppose you know the slope of a line. We're going to underline that. And the coordinates of one point. We know that. How can you write an equation of the line? Well, let's go ahead. We know the slope of my line is 4. They tell us right here we have a point of 2, 1. So, if I wrote this, I wrote m equals y minus, well, there's our y value. We'll say that's the y we plug in, and there's our x value that we plug in. And, you know, let's take the m out. Let's put in 4. All right. Now, what you can do here is you can take your 4, which is over here, and your y minus 1 and x minus 2, and you can get rid of this fraction by multiplying both sides by x minus 2. Right? If I do that, these guys cross off, and that gives me y minus 1 equals 4 times x minus 2. Alright? So this equation that we've derived, and it's written in this form, is called point slope form. Right? The equation y equals 2x minus 1 is slope intercept form. How can we write it in point slope form? Well, what I'm going to do is I'm going to put the slope and the x values on this side. So, well, in this situation, okay, we would have to understand that the y-intercept is, well, let's do the y-intercept, right? We have a slope of 2, m equals 2, okay? We have a y-intercept of 1, so the y-intercept is 1, and we would plug all that in. So in this case, we would say, so here we go, where's our, this point right here is 0, 1, and I'm going to go ahead and give you a point slope form. Point slope form is this: y minus y1 is equal to m times x minus x1, and I'm going to say y minus a known number. In this case, the known number for y is 1, equals m times x minus a known number, so x minus 0. And there we have point slope form. Okay? Now, we're going to keep going. Creating a linear equation given point slope form, and they give it to us, right? Point slope form is this, something that should be committed to memory. Y minus y1 equals m times x minus x1. So if I'm given a slope, slope is 0, kind of tricky, I'm going to say y minus y1, right? Y minus the negative 1 that they give us as a y value. Here's my x value, equals m, which is 0, times x minus x1, x minus, in this case, negative 2. Well, 0 times all this turns into 0, and that turns into a plus 1, and we're done. Alright, let's keep going a little bit. Opposite side of this. Okay. Suppose you are given the slope of a line as 0. What is the only additional information you need? Well, if you look over here, everything over here dropped off. So the only thing we really need to know is a y value. So the only thing we need to know is, I'm going to say, is any y value, because all the y values are the same, right? I'm going to add that. All y's are the same. There are jokes in my head that are not coming out. Write an equation in point slope form for each line. Alright, so we're going to write it here. Y minus y1 equals m times x minus x1, and here we go, y minus, in this case, 2 equals m6 and x minus 1. We're going to stop there for now, although our goal is to go from somewhere else pretty soon. Do the same thing. Y minus 1 is equal to m times x minus negative 3, which is the same as plus 3, and I should take that m out and write in 1/3. Alright, so we're going to stop with that. That was the first page and a half, and we'll continue on creating linear models given slope and a point.